Hello, this screencast is going to walk us through the basic concepts of analysis of variance, or in this case here specifically single factor or one-way ANOVAs. I'm going to use an Excel sheet here to kind of highlight what happens in the process of an ANOVA. As you can see here, I have three groups set up. And you can have more than three. You can have 10 different groups. And the point of an ANOVA is it's the initial test we run to determine whether or not any one of the groups or more than one of the groups is basically not in sync with the others. Is there a group here that is an anomaly? Something different is going on with that group. Or maybe you can have more than one group. And it's in a situation where if we only had two groups, we would run a t-test. But because we have multiple groups, we don't want to run multiple t-tests with every possible pairing. So the ANOVA is a single method to identify if, in fact, there is at least one group that is out of the ordinary or is statistically significantly different than the others. And what it's comparing is this. We're trying to take a look and compare, is the variation that is taking place in these numbers between the groups greater than the variation that's taking place within the groups. Anytime you have a set of data, you're going to have some type of variation in real life. And if you take a look at this set, we have it set up so that at first glance, you can see group one, most of the numbers here are on the low ends of the single digits. Group two, the numbers are set up so that we're in the upper end of the single digits, or in fact double digits here with 12. And then group three, they're all clumped between 15 and 20. So the variation taking place within this group one is not that great. The majority of the numbers are within the range of 1 to 5. Same thing here with group two. You can see that the numbers range between 6 and 12, so they're clumped together in that group. And then likewise with group three. However, the variation between the groups, you can see that, for example, here, just from this bottom row here, from 3, 8 to 17, there's much more variation going on between the groups than within. In an ANOVA, ultimately what we're taking a look at is what is called the F ratio. And the F ratio is the comparison between the amount of variance identified or measured between groups over the amount of variation within the groups. And I'm not going to go into the actual statistics of it. You can get that in the text and in our notes. But I thought this screencast would help identify what's going on within these values. Now, right now, this is set up so that the F ratio is pretty large. 107.27 is a fairly large F ratio. And we're going to talk about that in a second, what that means. But let's take a look at the data here. Let's say, for example, I move the data around so that some of these values that are in the higher end get dispersed in some of the other groups, and some of the values in the lower end get dispersed in these groups as well. And we mix it up a little bit so that the variation between the groups is not as great as it was. We're spreading out these larger numbers and also spreading out these lower numbers. And I'm going to set them up so that the cells end up being basically in the same locations here. And you'll see, even though there's still variation within, the variation within each group has increased. Now these values go from 3 all the way up to 19. These goes from 1 to 20, and so on. That the variation within the groups, which is measured here, has increased greatly Whereas actually between the groups, if you go from one group to the next, they look relatively the same. And this value dropped significantly. And therefore this ratio, or this fraction, which was very large before, where the yellow was much greater than the blue, in this case here it's switched. And you'll see that the F ratio dropped all the way pretty close to 0, 0.04. Now, what does that mean? If we take a look at, in this case here, it's an F distribution. All right. What we're doing is we're taking a look at two major values we have to pay attention to. Number one is the T critical, or the critical T value. That value is determined by looking up the values in the table based on the degrees of freedom, and in this case here, there were 3 groups, so the degrees of freedom of the number of groups in the numerator is 2, and there were degrees of freedom within the groups was 18. That's determined by the number of data points, which was 21, divided by the number of groups. Subtract the number of groups of 3 to give you the 18. That table established a value, if you looked it up, of 3.55. That is the F critical for this type of grouping, where you have 3 groups and you have 21 values total within those 3 groups. For every scenario, that changes, and that's why the table C in the back of the book is so important. Then what we're doing is we're taking a look at this calculated F ratio and comparing it to the critical F. So if you can imagine, this value of 3.55, that's the value right here, that's the make or break point. That's your decision point. And then this F ratio in green, 0.04, depending on where that lies, whether it's on this side of the critical value or this side, depends on whether or not you reject the null hypothesis. And in this case here, after I moved the values around, that made the F ratio way up to the left here, very close to 0. Not even close to at all that critical value of 3.55. And in this case here, we accept the null hypothesis. The null hypothesis in this case would be that there is no significant difference between any of the groups. And if you recall back when I had it arranged with the largest numbers in column 3, I'll mix these back around, and as I do that, you can see that these values are changing over here. The amount of variation within the groups is dropping because I'm clumping these values basically to values that are alike each other. I have the upper teens in the one set. I have the lower single digits in the other. And I think we have it rearranged now to where it was in the beginning. All right, and you can see now that F ratio increased tremendously. And now at this point, it is compared to the critical value, which again doesn't change. That's based on the degrees of freedom here of 2 and 18. That value of 3.55 is fixed for this scenario. That F ratio here is now 107, which is way up in the tail, which is basically saying that we reject the null hypothesis and we accept the alternate hypothesis that there is a significant difference between these groups. It's not by chance. This F critical is usually set up, in this case, by default of 0.05 alpha, which means that the area under the tail here is 0.05. The area to the left is 0.95. And that's basically saying that the probability of this occurring, which is the p-value here, which is very small, is so low that we are not saying that it might be by chance. But in this case here, that there is definitely something going on here between these values, and then there is a significant difference between the groups. I hope that helps. Thank you.